AASHTO T176, commonly called the sand equivalent test, is a quick test to show the relative proportions of fine dust or clay-like material in soils or graded aggregates. In this tutorial, we will use a mechanical shaker and the sample will be prepared by alternate method number 2, pre-wet. For this test, you will need a plastic graduated cylinder and a rubber stopper, a flexible siphon hose, an irrigator tube, a weighted foot assembly, a 1-gallon jug, and a shelf capable of supporting the filled jug at a distance of 36 plus or minus 1 inches above the work surface. The apparatus must meet the specifications shown in Figure 1. You will also need some 3-ounce tins and a spatula or other straight edge, a balance, funnel, timer, shaker, a drying oven, a quartering cloth, a number 4 sieve, a soft brush, and a stock solution diluted to a working solution in distilled water. Make sure your equipment conforms to the specifications found in Section 4. Maintain the temperature of the working solution at 72 plus or minus 5 degrees Fahrenheit during the test. Obtain a sample of the material to be tested in accordance with AASHTO T2 and reduce it to testing size according to AASHTO T248. Be sure the reduced sample is of sufficient size to yield from 1,000 to 1,500 grams of material passing the number 4 sieve. Shake the sample over a number 4 sieve. Make certain that all -4 material passes through the mesh. This includes any aggregated material such as clay lumps, as well as any material adhering to the +4 particles. Discard the material retained on the number 4 sieve and reduce the -4 material to testing size between 500 and 750 grams. Take special care to maintain the representative nature of the sample during this final reduction. Smaller samples are more difficult to reduce to representative portions. It may be necessary to dampen the material to avoid a loss of fines. Before beginning the procedure, the sample must be in the proper moisture condition. This is determined by performing the fragile hand cast. Thoroughly mix the sample, then tightly squeeze a small portion in the palm of your hand. In the proper moisture condition, the material will retain its shape and endure careful handling without breaking. The test sample may be obtained immediately from material in this condition. If the cast crumbles, the material is too dry. Increase the moisture by adding a small amount of water, remixing, and retesting. Repeat this moistening procedure as necessary until a cast is formed. If the material is too wet, a good cast will be formed, but free water will be present. Material in this condition must be air-dried and mixed frequently to ensure uniformity. When the proper moisture condition is reached, the material must be tempered before obtaining the test sample. To temper the material, place it in a pan and cover with a lid or damp cloth. Make sure the cover does not come in contact with the sample and let it stand for a minimum of 15 minutes. After the 15-minute tempering period, mix the material in a quartering cloth by alternately lifting each corner and pulling it over the sample toward the diagonally opposite corner until the material appears homogeneous. Fill the 3-ounce measure by pushing it through the base of the pile while exerting pressure from the opposite side. Firmly compact the material so the measure holds the maximum amount allowable. Strike off the material with the straight edge, leaving the measure level full. Since we are using the reference method, the test samples must be dried to a constant mass at 230 plus or minus 9 degrees Fahrenheit, then cooled to room temperature before testing. Begin the test procedure by making sure the siphon is ready for use. Siphon 4 plus or minus 0.1 inches of working solution into the graduated cylinder. Place the funnel in the cylinder and pour the test sample into the solution, taking care to avoid spillage. Remove trapped air by tapping the bottom of the cylinder firmly with the heel of your hand. Allow the wetted sample to stand undisturbed for 10 plus or minus 1 minutes. After the 10-minute soaking period, loosen the material from the bottom by tilting and shaking the cylinder. After loosening the material, place the stoppered cylinder in the mechanical shaker and allow the machine to shake the cylinder for 45 plus or minus 1 seconds. At the end of the shaking period, set the cylinder upright on the work surface and remove the stopper. Insert the irrigation tube and rinse the walls of the cylinder as the tube is lowered. Apply a gentle stabbing and twisting motion to force the tip of the irrigator through the material repeatedly to bring the fines into suspension. When the solution level begins to approach 15 inches, raise the irrigator while maintaining flow and keep the level just below the 15-inch mark until just before the irrigator is withdrawn from the solution. At this point, regulate the flow until the bottom of the meniscus is between the 14.9 and 15.0 inch marks, and immediately start the timer for the sedimentation period. If the irrigation is insufficient, fines will still be present in the material at the bottom of the cylinder. When properly performed, virtually all clay particles will be suspended after irrigation. Let the cylinder stand undisturbed for 20 minutes plus or minus 15 seconds. At the end of the sedimentation period, record the level at the top of the clay suspension. This is the clay reading. Then, take the sand reading using the weighted foot assembly. Carefully lower the assembly into the solution. Take care to avoid bumping the mouth of the cylinder with the indicator. As the foot touches the sand, tilt the assembly until the indicator touches the graduations on the side of the cylinder. Read the graduation at the extreme top edge of the indicator and subtract 10 inches. This is the sand reading. If the reading falls between graduations, record the reading as the higher mark.
Calculate the sand equivalent to the nearest 0.1 using the following formula. Simply divide the sand reading by the clay reading and multiply by 100. If the answer is not a whole number, raise your answer to the next whole number. If you are averaging the results of multiple tests, raise each individual result to the next whole number before calculating the average. Let's look at an example calculation where we are averaging the results of 2 tests. The results from test 1 are sand reading equals 3.4, clay reading equals 6. 3.4 divided by 6 equals 0.567. Times 100 equals 56.7. Raising the answer to the next whole number, the sand equivalent from test 1 is reported as 57. The results from test 2 are sand reading equals 3.5, clay reading equals 6. 3.5 divided by 6 equals 0.583. Times 100 equals 58.3. Raising to the next whole number, the sand equivalent from test 2 is reported as 59. Remember, answers for sand equivalent are not rounded to the nearest whole number. They are raised to the next whole number. Average the results from both tests as follows. Reading 1, 57, plus reading 2, 59, divided by the number of tests, 2, equals the average sand equivalent, 58. Averages should also be raised to the whole number if necessary. For example, if you were averaging the results from 3 tests with results of 55, 56, and 58, The average, 56.3, is reported as 57. Always report the sand equivalent as a whole number.
For more details on the most recent specifications, consult the latest AASHTO publication, which may be ordered by calling 202-624-5800 or online at transportation.org.